Okay, so we have seen a lot of applications for solving linear equations. And so far, the way that we've been able to decide what technique to use was to look at the top of the worksheet and see what technique this problem called for. In real life, when we encounter problems, we can't look at the top of the worksheet. So, in real life, when we encounter problems, how should we approach them? And in order to show you an example of this, I'm going to give you a problem of a type that we haven't really seen before. So suppose we're told that a cook has 8 ounces of ground beef that's 20% fat by weight. She wants to add ground beef that's 8% fat to get a mixture that's 15% fat. How much of the leaner ground beef should she add? Okay, well, we see percents in this problem, but this is not a straightforward percent problem. It's not asking us how much fat is there in the 8 ounces of ground beef, right? When we see a problem that is not straightforward, our very first step should be identify the question. In this problem, how much should she add is the question. So we're looking for an amount of ground beef. Looking at the rest of the story again, it's probably going to be some number of ounces of ground beef, since we're identifying an amount of ground beef in ounces a little bit earlier. Let's give that a name. Let's say X will be the amount of ground beef added, and we expect that that's going to be measured in ounces. And don't just think that. Actually write that down. Because later on, when you've done a bunch of calculations, you're going to want to be able to look back here and see, what did my X represent again? Have I found the answer to my question? Okay, so we want to know how much ground beef she's added. Next, I'm just going to look through the story and say, what kind of information do I have? Right. So, just looking through the story, I have information about percents of fat. And the main thing that's happening in this story is that things are being put together. Now, things being put together suggests adding, but it typically doesn't make sense to add percents together, right? If I mix 100% juice with another drink that's also 100% juice, I do not get a drink that's 200% juice. And at this point, we notice we're starting to stray from just identifying information. But that's really all there is. Really all that we know is about percents of fat. So at this point we're ready to go to step 3, identify a strategy. Right, so when we were looking at our information, we noted that maybe we want to add, but not percents. What can we add together? Well, those percents are telling us about how much fat is in this mixture. Maybe we could add together the amount of fat in the mixture. It would certainly make sense to add together the amounts of fat, so that's a strategy that makes sense. Once we've identified a strategy, we give it a try. Right? So our strategy has to do with adding together the amounts of fat. So we want to know the amount of fat in the first ground beef, the amount of fat in the second ground beef, and then the amount of fat in the mixture. Right, okay, so the amount of fat in the first ground beef. The first ground beef has 8 ounces that are 20% fat by weight. So that's easy. That's going to be just a number. We'll have 20% times 8 ounces. That's working really well so far. The amount of fat in the second ground beef, well, it's 8% fat. How much of it do we have? Oh, that's X, right? The amount of the second ground beef is our X. So the amount of fat in the second ground beef, that's going to be 8% of X. Okay, what about the mixture? The mixture is 15% fat, but how much of it do I have? Uh-oh. It's going to be 15% of something. Okay. Does that mean this didn't work? Let's think. How do we decide if this is working? Well, okay. First of all, if our unknown doesn't turn up anywhere, we're not really doing something useful. In our case, yeah, our X turns up right there, so we're okay. And let's see. The other thing to look for is, are there any other unknowns in this problem? In this case, we have this extra unknown, right? The total amount of the mixture. If there are other unknowns, we need to look for more information. Our goal, ideally, is to write the other unknowns in terms of the first unknown. Right? So, can we write the amount in the mixture in terms of how much we're adding? Well, if we have 8 ounces of something, and then we mix in X ounces, oh, yeah. The total mixture is going to just be 8 plus X ounces. Okay, that wasn't so bad. We can go up here and fill that in. Okay, and now these are amounts of fat. If I add together the amount of fat from the first ground beef and the amount from the second ground beef, I should certainly get the amount in the mixture. So my 0.20 times 8 plus my 0.08 times X should be the same as my 0.15 times 8 plus X. Hey, this is actually going pretty well now, because this is an equation I can solve. Before I do a bunch of algebra, though, I want to make sure that this makes sense. Right, so this is a number of ounces. This is a percent of a number of ounces. So this whole term is in ounces. X will be a number of ounces. This is a percent of a number of ounces. So this whole term will be a number of ounces. I'm adding ounces plus ounces. Good so far. 8 is a number of ounces. X will be a number of ounces. It makes sense to add those together. This is a percent of a number of ounces, so this whole term will be in ounces. I'm adding ounces plus ounces and getting ounces. That makes sense. I'm mixing this with this and getting this. That makes sense. We've just done step 6. Once we have an equation, we can use dimensional analysis to make sure that our equation at least makes sense. Alright. And now we just have an equation, right? Now we just do a bunch of algebra. So let's see, what should we do? Well, I'm going to do this arithmetic, certainly. It would have been okay to do that before. We've got 1.6 plus 0.08x equals. Here I'm going to distribute. Let's see. 0.15 times 8 is 1.2 plus 0.15x. Okay. Now I notice I have x's on both sides. I want to get rid of the x's on one side. I'm just going to get rid of them on the right. I get to choose. I'm going to choose that one. So these terms cancel out. And 0.08 minus 0.15 is negative 0.07. Okay. And now I need to get rid of the 1.6 on the left. I'm going to add negative 1.6 on both sides. Negative 0.07x equals 1.2 minus 1.6 is negative 0.4. Finally, I need to get rid of the negative 0.07. Those will cancel, and I'm just left with x. My 0.4 over negative 0.07 is about 5.714 dot dot dot. Okay. So now we have the value of x, and we're ready for the very last step. We want to answer the question and see if our answer makes sense. So, okay, back to the story. The question asked, how much ground beef should she add? And we let x be that amount of ground beef. So our value of x is the answer to the question. Let's see, we got an awful number. We'll make it into a mixed number, that's okay. Does it make sense to add 5 and a bit ounces of ground beef? Yeah, sure. So, she should add 5 and, let's see, take off the 5, get a fraction, 5/7. 5 and 5/7 ounces of ground beef. Right. What kinds of numbers wouldn't make sense? Well, if we'd gotten some huge number, we would have been very surprised and gone back and wanted to check our work. Same with some tiny number. If we'd gotten a negative number, that would make absolutely no sense. Either we set up our problem wrong or what she's trying to do is impossible. This is a perfectly sensible answer to this question. So, what was our process here? And I'm not talking about answering this question. I mean our process for approaching this problem. First, we identified the question and looked through the story and said what kind of information we had. We came up with a strategy and we gave it a try. Right? We hit some snags, but we came up with a way to overcome them. If the strategy we came up with had not worked, we could have gone back and tried to come up with a different strategy. Right? We made sure that our equation made sense before we went to a lot of trouble using algebra. And then we used algebra to solve our equation. Finally, we took our solution back and we answered the question with it.